All living things have a common property called irritability, which is revealed by their reactions to stimuli. In the present picture, the pricking is the stimulus, and the reaction is the quick withdrawal of the hand. The energy used for the pricking is very small, but the resulting reaction involves generally a much larger amount of energy. This is characteristic of all manifestations of irritability. An illustration based on directed motion in non-living matter is shown here. We scatter iron filings on a glass plate and hold a powerful magnet under it. If we tap the plate lightly, the magnetic field gradually causes the filings to form a pattern. The filings are moved by the tapping. The definite pattern is determined by the magnetic force. If iron filings were living things, we would have called this oriented movement a tropism, from the Greek word meaning I turn. If we remove the magnet and tip the plate, the filings are now influenced only by gravity. Therefore, they slide off the plate. Reaction in living things to the change in direction of gravity is called geotropism. Most organisms show this reaction. Plant stems show plainly the so-called negative geotropism, which makes them grow vertically away from the earth. This in itself is a reaction to gravity. We can disturb this normal reaction by placing the plants so that their stems are horizontal. If we do so and leave the plants in darkness for a few hours, we find that the stems have turned away from the earth, so that their tips again point upward. It may be simpler to say that plant stems normally point vertically upward, and that any change in position determines a reaction which brings them back again to a vertical position. Many trees show this reaction. Here is a bent tree. It reacted as the seedlings did, bending up gradually. For purposes of study, however, this bending can more easily be followed in small oat seedlings. See how they react. First, there comes a slight bend close to the tip, which gradually increases until the tips are pointing upward again. Here again, you can see another plant reacting to a change in position. Every time a plant is stimulated by a change in position, the same reaction occurs. Animals, too, are sensitive to a change in position. Here is a common snail crawling on a vertical plate. Notice that it is moving in an upward direction. We then revolve the plate so that the snail is crawling horizontally. Immediately, its shell drops and its head turns to the new upward direction. Gradually, the body turns until the snail is pointing up again. In animals, we can get this reaction clearly only when the animal is actively moving. All animals, even human beings, show this reaction more or less distinctly. Phototropism, another reaction of all living things, is determined by light. An organism turns toward or away from a source of light. To demonstrate this turning reaction, we use an oat seedling. Grown in total darkness, it was straightened vertical. Exposed to a constant source of light placed at its left, the seedling bends toward it in the course of 4 hours. Many animals show phototropism. The fruit flies in this tube are scattered all about under the influence of light coming from all directions. Suddenly we turn off all but one strong light at the right end of the tube. Gradually most of the flies collect at that end. The single strong light was the directing stimulus. The movement of the flies toward it was the reaction. Stereotropism, or directed response to contact, can be observed in plants. A young tendril has been brought in contact with a stick. Slowly this tendril winds itself around the stick, as we see a few hours later. The contact with the stick has been the stimulus. The twining has been the reaction. Even animals show stereotropic reactions. Notice this mouse. Its running along the wall is determined as a reaction to touch. From time to time, side movements seem to indicate a tendency to lose contact with the wall, but the mouse very soon returns to it. All mice generally follow walls. Other tropisms are known, for instance, to the electrical current. A worm, when placed across the electrical field, will turn both ends away from the positive pole, which the arrow indicates. If we reverse the current, the worm turns the other way. This is a true tropism, a directed reaction to a stimulus. Fishes, on the other hand, react to the direction of a current of water. In one picture, the floating strings are forced out of the vertical position by the current of water, which the fish always face. If we reverse the current, in a few seconds the fish have turned so as to head against it. Such a reaction can frequently be seen in rivulets and streams, where schools of minnows and other small fishes swim in large numbers with their heads pointing upstream. Note how quickly these fish react to the change in current. Even if they do not progress forward, they will always swim in such a direction that the current will not carry them downstream. Higher reactions are the result of the interplay of different stimuli. Some plants, such as the Venus flytrap, are called sensitive plants for their quick reactions to touch. In the center of each half of the hinged leaf are 3 stiff hairs, which at the slightest touch will cause the closing of both halves. The stimulus is applied directly to the hairs, but the hinges close the leaf, so some transmission of effect from hairs to hinge must have occurred. The true sensitive, or mimosa, is the most famous of these reacting plants. If we touch the tip of a leaf gently, we notice that first one and then another of the leaflets fold over. Then if we stroke harder, the whole set of leaflets folds over. In every case, the stimulus is transmitted away from the point where it is applied. Animals will show reactions of the same order. The puffer fish, when handled or rubbed on the belly, puffs up and expands a great deal. The stimulus was the scratching of the skin. The reaction was the puffing up of the entire body. Many organs far from the point of stimulation are brought into play to produce this result. Some reactions in higher animals are absolutely involuntary. If we rub this dog's back, his hind leg scratches his side vigorously. This can be done over and over again. It is a true involuntary reaction. The same is true of the kicking reaction of the leg.